ハンダ盛り良好。電極の輝きも問題なし。
I let the leads fall through until I feel the shoulders seat on the chassis. Orientation matters, so I keep the stripe toward ground. Once it's sitting flat, a little pressure locks it against the plate. The next one...
The solder wets the pad, climbs the lead, and settles into a perfect dome. Surface tension does the final shaping. All that's left is to breathe and let it cool.
Every turn has to sit exactly beside the last one. A fraction too loose, the whole transformer will sing the wrong note. It's slow work, but music rewards patience. You can hear it in the silence between notes.
In a quiet corner of the workshop, Heatsink specialist Noboru Watanabe aligns a block of anodized aluminum with the amplifier's power transistors, a fit measured in fractions of a millimeter.
13.980 in our bore. 8.002.
Channel 2 rises clean at 1 kilohertz. Good response.
Copy that. Logging it now.
Switching to 4 ohms load.
Ready?
This lead has to run under the bus bar and come up beside the heater pair. I slide the marker first, then give it enough slack to breathe. Into the lug, you should feel it bite, but not crush the copper.
よし、温度がちょうどいい。ここ流し込みます。表面張力で、そう、綺麗に丸く。いいね。ぴったり集まった。
断面綺麗。表付けも浮きなし。コイルの固定良好。熱シンクフィンの曲がりなし。問題なしですね。
よし、角度そのまま。ゆっくり下に入った穴合わせて。そう、ここで固定だな。
Gold film capacitors, 10 microfarad 50 volt. They go here. Precision resistors, 0.1% tolerance. I check each sleeve before it leaves storage. Everything's where it should be.
Nice. No jitter on the rise. Square wave's clean. Amplitude's right where it should be. A little trim. Yep, that locks it in.
Aligning on the pins. Set to torque. Perfect fit.
Setting torque to 1.8 Newton meters. Threads engage cleanly. Listen to the ratchet. There's the brake. Perfect seat, no distortion on the bracket. Moving to the next fastener.
Blue band, 1% tolerance. Green and gold, 5%. Each value reads like a note in a chord. You just have to keep them in tune. When they sit in the circuit, the sound will be honest.
Silver-plated copper is a little stiffer, so I score rather than bite through. Let the blade do the work. Once the strands are clean, we give them a thin coat of solder. The tinning keeps them together and stops oxidation.
You want it to look almost translucent. Any high spots trap heat, so the trick is even pressure and shallow passes. The paste should just veil the machined marks, no more, no less.
Aligning on the pads. There we go. Always listening for that little hiss. Perfect contact.
Guided by the rig's micrometer controls, Murakami lowers the finished amplifier chassis into the final testing station, its weight balanced perfectly on precision pins. A gentle press seats the unit.
Center to center 2.4. Good. Pin 2 just a hair clockwise. There. Tension feels even.
9.998 kilo ohms within 0.02%. Logging 10.004. Also good. Pass.
Output's locked at 15 volts 1 amp. Ripple holding under 2 millivolts. I'm jogging the load a little. Watch how the regulator corrects. Stable. That's what we want for the amplifier stage.
Just chasing the edge. Keep it even. That's better. A few strokes to break the corner. Clean, ready for anodizing.
Surface tension does the shaping for you, and when it freezes, you have a joint as strong as the copper beneath it.
Every amplifier that leaves here has already lived a lifetime. We simulate years of music, heat, and silence, waiting to see what gives first. Sometimes the answer is silence. Sometimes a...
Power on.
There. Set screw snug. Smooth travel. Perfect.
$130 million. Good. Next up, 115.
By laying a microscopic film over the components, we seal them from humidity, salt, and dust. The trick is to move slowly enough for the liquid to level, but not so slow it pools. Each
The sweep plots out the amplifier's response from 10 Hz to 40 kHz. We're checking for any roll-off.
With tweezers and gloved fingertips, internal wiring specialist Akemi Fujita seats each signal line into the comb. A micro cable tie cinches and snips, no movement left to chance. Power leads are
The interface begins with a single gold-plated pin. The plating is only a few microns thick, yet every contour must be flawless for a signal this sensitive.
Bringing it up 2 mils, holding, perfect, back through center, zeroed, probe off, tracking is true.
ピンの隙。よし。押し込みます。
Each reel has to be seated with the tape perfectly centered on the sprocket. If it's off by even half a millimeter, the placement head will mispick and the line stops. Lock it, advance, check tension, simple.
音角が揃うと時速の流れが乱れません。1枚ごとに向きを確認して、ここでピタリと重なると気持ちいいですね。
98% efficiency, solid.
This braided copper strap links the chassis directly to earth ground. I seat a stainless washer under the ring so the pressure is even. You tighten until the driver clicks.
Bringing bias up just a hair. There, 90 millivolts. Perfect. Rock solid.
The lead must turn exactly 90 degrees. I let the tool set the angle and keep the stress off the body. Trimmed at 6 millimeters, clean cut. Perfectly.
Every part has a home, and every home has a record. When I slide a pouch in, the system knows exactly which drawer and which slot. That way, tomorrow or 5 years from now, we can find it.
根邪魔が噛む感触を確かめて、トルクは 0.6 ニュートンメートル、音が変わる。熱伝導パッドが均等に潰れているのを確認して、よし。
Every dimension we trust in the factory begins here. We check the reference blocks, confirm the micrometers, the indicators, everything, down to 50 nanometers. Consistency.
Glass pack, turn the nut down by hand, top 0.8, listen for the clicks, perfect, feel the detents clean and even, wipe it down, alignment looks good and that's locked.
Each connector is verified one by one. I check the impedance curve first, then sweep the frequency to be sure there are no resonances. When the waveform locks in like that and the tolerance is within half a...
収縮チューブ集めて、はい、完成です。
Every pad needs just the right amount, no more, no less. Pressure steady, tip clean. The paste should sit like tiny pillows. Too tall and parts float. Too short and they starve.
The index line has to fall exactly on zero. If it's even half a degree off,
The switch inside doesn't seat cleanly. Feel that resistance? That is a cam looking into the follower.
Surface is uniform, no lines. Light passes, keeps the sheen alive.
Laser etched, 47 microfarads, good tolerance, encoder seat feels right, zero play, 10 kilo ohm, 1%, snug in its lane, everything flows when the numbers line.
Binding post goes through cleanly. Thread shows. Washer, spacer, nut. Listen for the seat. Torque to spec, there. Cap on, red ring aligned. Wipe the surface. Solid connection, just
964. All three units are holding voltage within 2 millivolts. Humidity at 80%. Chamber temperature cycling between 5 and 40 degrees. No drift and noise floor.
Sweep looks clean. Noise floor is sitting at minus 103 dB. Harmonics well below spec. Locking that in and storing results.
合格がぴったり決まると気持ちいいんです。これで世界のどこへ行っても無事に届きます。
Tiny eighth of a turn response drops 4/10 of a dB, now bringing the high band back up there, flat to 12 kHz. Noise floor looks good.
Keep the body flat. Film cap 100 nanofarads align with the mark. And the blue ceramic seated. Good.
Sliding forward, light tells me the story of the surface. Small ripple, right at the edge. Dim it, there, wipe.
Each module here is driven to its limits. Voltage, heat, vibration, long before it ever leaves the building. We're watching how fast it ages, figuring out what will fail first. The data tells the story in real time. My job is...
Leads go through clean, no tension. Rotate alignment on the silk screen. Spacing is perfect. They sit like twins.
Serial number 703, distortion point 004%. Signal to noise 192. Stamp. Unverified. New sheet, same care.
Tip, pad, then wire. Let the heat do the work. Feed a breath of solder and stop. Smooth, even flow, shiny as a mirror. Solid. That is a proper joint.
When we push for a quieter amplifier, it means chasing noise we can barely measure. This simulation lets me see how every trace and every component breathes under load. The prototype on the bench is already matching the...
This is the first of the bulk filter caps. Leads are lined up with the positive and ground posts. Clamp goes on, torque to spec. Now I can land the positive feed and crimp it down. Solid. That should keep ripple well...
Just a fraction more. There. Bias resting at 40 milliamps. Let it settle. Perfect. That's the sweet spot.
Control seats tight, and flaps along the rail. Space plate clean. Label goes up.
Good. Keep the pace steady, lines at 96%.
The protector relay drops straight into the terminal block. These screws lock the pins without stressing the board. Next, the thermal sensor is
Pretty good. Just touch up on the gain, yes.
The braided strap ties the bus bar to the ground plane. I seat the star washer first, that bites through any anodizing. Torque to 1 Newton meter, you can hear it settle. No movement, low impedance, and the loop area.
最終スイープ。20キロでマイナス1デシベル。ノイズフロア安定。使用確認完了。
Yesterday's defect rate held at 0.3%, so we're steady. The issue is cycle time. We're still 8 minutes over target.
I flagged the bottleneck on the inspection station. See the red bars? It spikes every second shift.
Rotating to 0.5, verified. Track engage. Running test. And passed. Final position locked. Calibration complete.
ちょっとね、始めるじゃう。で、これじゃあ、次ほげた。ですね。ちょっとね、始めるじゃうですね。
Rows of finished amplifiers wait for their final journey. Every unit here has passed inspection, packed and labeled for destinations around the world. From the brushed aluminum faces to the foam lined crates.
Switching to mains and power on. Indicator present, rail climbing, 32 volts, self-test tone clean, standby engaged, looks solid.
Amplifiers. These amplifiers are born from decades of careful listening and meticulous craft. Each chassis is milled from a single block of aluminum.
Label centered, pressing down the corners. That's for Stockholm dealer code 118.
Scale reads 7.45 kilograms.
Perfect. Scanning now. All right, ready for pickup. Manifest updated. Next one up, Chicago.